Hey everyone, Mr. Armitage here, and in this video, giving a little extra example of constructing a confidence interval for a difference of proportions. Okay, so here we have an example, okay, pulled straight from Sapling, actually. A poll of 40 randomly selected wives revealed that 70% of their spouse 70% said their spouse is their best friend. A random sample of 100 husbands found that 81% said their spouse is their best friend. Construct and interpret a 90% confidence interval for the difference in the proportion of wives and husbands that would say their spouse is their best friend. Okay, so here's more or less what we do. Right, first thing we want is to identify what are our sample proportions, right? So say P hat W, okay, that's the wives, so that's 0.7, okay? So that's from there. Okay, then we also have P hat H, right, for the husbands, 81%, so 0.81. Okay, we have those, and ultimately that's all we need to, well, partially all we need to get started. Okay, the sample size for the wives, right, is 40, and the sample size for the husbands is 100. Okay, so we have that. Now we are saying, right, we want the confidence interval for the difference in proportion of wives and husbands that would say their spouse is their best friend. Okay, so we are finding the confidence interval proportion of wives minus the proportion of husbands. Now we don't have these particular values, but we do have our sample values here. So of course we should, in general, check the conditions. Okay, so first condition, are our samples random? Yes. Right. Randomly selected, a random sample. Okay. Yes. We would want to say or write, right, randomly selected random sample, right? So, or like, okay, there we go. 2, 10% condition. So, are the number of wives in our sample less than 10% of all wives in whatever group we're looking at? Okay. So, are 40 wives less than or equal to 10% of all wives? Yeah, probably, right? Even looking at a small town, okay, there's probably more than 40 married couples. So there's definitely, well, more than 40. There's probably at least 400 married couples. Okay. So, yeah, right? All wives is very big. And same thing if we're talking about 10% of all husbands. Okay. That all husbands is very, very big. And so 10% of that, right, 0.1 times the number of husbands is also going to be very, very big. And so 100 is definitely a lot smaller than whatever number we get there. Now for large counts, okay, we need to check that the expected number of successes or the number of successes and the number of failures in each sample is at least 10. Okay, so we do that by taking our sample size and multiplying it by our p hat value, 0.7. And we're seeing if that is at least 10. And we also need to check if 1 minus our p hat value is at least 10. Okay. So 40 times 0.7 is 28. And yes, 28 is bigger than 10. Okay. That would also mean that this here is 12, and that is bigger than 10. Okay. Now that was just for one sample. We need to check both samples, which is not too bad, right? 100 times 0.81. Okay, that's going to be 81, and 81 is bigger than 10. Okay. And also 100 times 1 minus 0.81. Is that going to be bigger than 10? And spoiler, yes it is. 19. Right? 19 is bigger than 10. So yeah, we meet the random, we meet the 10%, we meet large counts, right? You need to show these things if you are actually checking the conditions, because just saying random yes, 10% yes, doesn't actually show me that you understand what is the 10% condition. Okay, now we can do our calculations. Okay, now, of course, we could do the long calculation. Right, we're doing wives minus husbands. Okay, so we'd have P W hat minus P H hat, right, plus or minus our critical Z value, which we'll go over that again, okay, times the square root of PW hat times 1 minus PW hat over NW plus PH hat times 1 minus PH hat over NH. Notice everything is inside of this single square root. And so we could do, right, 0.7 minus 0.81, okay, plus or minus, we'll talk about the z in a second, 0.7 times 1 minus 0.7 over 40 plus 0.81 times 1 minus 0.81 divided by 100. Okay, now our critical z, okay, z star, right? It's based off of normal distribution where, okay, right, center is 0. Okay, here's z star, here's negative z star, and all in here is the middle, in this case, 90%, because that's what we're finding, right? It said 90% confidence interval, so this is what we are looking for. Okay, a lot of ways of doing it. Okay, probably the easiest is to recognize that, do it in orange, this region right here is 5%. Okay, right, because there's 10% left over after the 90% split evenly into both sides, 5% each. So this is 5%. So we can use inverse norm with an area of 0.05. Okay. And I'll show you on the calculator how to get that. Okay. Okay. Want to go to distributions. So we have to press second and then this button here that says vars on it. And we see how line 3 is inverse norm, okay, 0.05. We leave the mean of 0 and the standard deviation of 1. Paste, enter, there we go. Oops. So this would mean that our critical z, we can ignore the negative because, right, this is negative z, 1.645. 645. Okay, we got that. That's all good. Okay. And then you can type this entire thing into the calculator and get our answer. Now, we could simplify it a little bit. So here we are. Negative 0.11. Okay, it's totally fine to have negative numbers when we are subtracting proportions because it just tells us that one of them, specifically the second one, is bigger than the first. Okay, and do that. So we could do 0.11 plus root and a lot of typing times 1 minus 0.7 divided by 40 plus 0.81 times 1 minus 0.81 divided by 100. There we go. So on the plus side, and we get negative 0.028. Did I get that all right? 91, yeah, 90%. Okay. Sorry. I was just checking something. Okay, and right, we can bring this thing back up, go through and do subtraction instead. And now we get negative 0.192. Okay, so we are 90% confident that the interval from negative 20% to negative 2.8%, or negative 19.2% to negative 2.8%, captures the true difference in proportion of wives and husbands who say that their spouse is their best friend. And if you'll notice, I made a mistake in my calculation. I forgot the 1.645. So let's go ahead and fix that. Okay, insert 1.645, right? Classic mistake. I knew I was missing something, so 1.645. There we go. Okay, so we have a positive 0.026, and now we have a negative, because we're going to subtract there. Okay, yeah, negative 0.246. Okay, so the interval from negative 24.6% to positive 2.6%. We are 90% confident that that will capture the true proportion or difference in proportion of wives and husbands who say that their spouse is their best friend. Now, notice we are going from a negative to a positive, right? This is now saying that we are 90% confident that there's no difference between the two proportions, right? Because in between a negative and a positive number is 0. Right? So it's possible that, proportion of wives, right, going back up here, proportion of wives is greater than the proportion of husbands. You'd say that their spouse is their best friend, in which case this would be positive. Okay, those are the positive numbers we got. It's possible that they're the same, because if these two numbers are the same, that's going to be equal to 0. Okay? We could have it positive. Okay? If wives is greater than husbands, we could have it equal to 0 if wives and husbands are the same proportion. And we could have it negative. Okay, if the proportion of husbands is greater than the proportion of wives. Now, these are our samples, okay? They came from these individual distributions. So we're trying to say overall is one distribution bigger than the other? And because we are going from a negative to a positive, okay, with 0 in between, we can't say that there's any significant difference between the two. Now, there is one other thing we could do instead. Instead of going through that entire calculation, okay, we could use two proportion z interval. Okay, stat tests, and we scroll down to two proportion z int. Okay, now our x1 is the number of successes. Okay, x1 n1, x2 n2. Okay, now I think the n's are fairly self-explanatory. Those are our sample sizes, right? So 40 and 100. So we'll change that, 40 and 100. Okay, now our x's, number of successes. Okay, remember these here, n times p hat. Those are the number of successes. Right? So the number of wives who said that their spouse is their best friend, and the number of husbands who said that their spouse is their best friend. And we also need to specify our confidence level. Let's see, 28, go, and 81. Our confidence level is 0.9, right? 90%. Calculate. Boom. We got the exact same thing that we did when we went about it the long way. Okay, so we don't have to go about it, this entire calculation. If we just need the confidence interval, we could just do this. Negative 0.2455, right? Same thing there. And positive 0.02553. Okay. Now I want you to notice something, right? Where is our p hat in this confidence interval? Right? Because we're going, sorry, tablet's a little upset right now. Oh, I see here. A new page. Okay, there we are. Okay. Right, this is negative 0.246. Okay. Up here is positive 0.026. Okay. Our p hat falls right in the middle. Well, how do we find the middle number between two values? Find the average. Right? Add them together, divide by 2. Okay. And you will find there we go. Find that you get negative 0.11. Or you should. Yes, negative 0.11, right? That was our p hat from before. So we know this did it all correctly, shall we say. Okay. There is calculating our two proportion or a difference of proportion confidence interval. Hope that helped. See you next time.